let's take a look at how to simplify radicals. Okay, so we'll start with something easy. Let's say you're given the square root of 25. Okay, well, since 25 is a perfect square, our answer to that is just going to be a whole number. It's just going to be 5, because 5 times 5 gives you 25. Now, sometimes you may be given a number under the radical that's not a perfect square. So, for example, 18. So what we want to do is we want to break this up into two separate radicals. We want to determine what's the biggest perfect square that divides evenly into 18. So that would be 9, because 9 times 2 gives us 18. We can break that up into radical 9, radical 2. And then you could say, well, the square root of 9 is just 3. Radical 2 doesn't simplify or doesn't break down anymore, so we're just going to bring that down. So our final answer would be 3 radical 2. Okay, now let's try some with variables. Let's say we have, put a number under here too, radical 48, x to the 5th, y to the 4th. Okay, so our goal here is to do the same thing. We want to break this up into two separate radicals, the first one being where we're going to put all of our perfect squares, and the second one being where we're going to put whatever we're left over with. Okay, so let's look at the 48 first. Well, there's lots of things that divide evenly into 48. I'm going to just make a list of them over to the side. We have 1 and 48. We have 2 and 24. We have 3 and 16. 4 and 12. 6 and 8. And I think that's it. Okay, so we want to find the biggest perfect square that divides evenly into 48. Even though 4 is a perfect square and that divides evenly into 48, 16 is our biggest perfect square that divides evenly into 48. So we're going to want to use the 16 and the 3. So what you do is you put the perfect square in the first radical and the non-perfect square in the second radical. Okay, now let's look at our x to the 5th. If something has an even exponent, it means it's a perfect square. So, for example, if we had x squared, that's a perfect square. The square root of x squared would just be x, because x times x gives you x squared. If we had x to the 4th, that's also a perfect square, because x squared times x squared gives you x to the 4th. If you had x to the 6th, that's also a perfect square, because x to the 3rd times x to the 3rd gives you x to the 6th. So as long as you have even exponents, these are perfect squares. All right, so if we take a look at our original problem, we have an x to the 5th under the radical. Now, a 5 is not an even exponent, but you want to pull out the biggest perfect square that you can out of this. So the biggest perfect square that's less than x to the 5th that you could pull out of x to the 5th would be x to the 4th, and that would leave us with an x to the 1st left over in our non-perfect square radical. Okay, and in the original problem, we also have a y to the 4th under the radical. Now, that is a perfect square because it has an even exponent. So let's just take the whole entire thing and move it under our perfect square radical. Okay, now that we took all the perfect squares out, let's just take the square root of each of these terms. So the square root of 16 is 4. The square root of x to the 4th is x squared. And the square root of y to the 4th is y squared. And then what we're going to do is we're going to bring the radical 3x down. Okay, so now let's talk about cubed roots. So if we had the cubed root of 8, all that means, that little 3 in the beginning of the little radical symbol there, just tells us what number can we multiply by itself 3 times to give you 8. So since 2 times 2 is 4, times another 2 is 8, the cubed root of 8 would be 2. Okay? If we had the cube root of 125, the answer to that would be 5, because 5 times 5 times 5 gives you 125. Okay, so let's try an example where we have non-perfect cubes under the radical. So let's say we have the cubed root of 128 x to the 9th, y to the 8th. Okay, so what we're going to do here is the same thing we did with the square roots. We want to break this up into two separate radicals. So we're going to have our perfect cube radical here and our non-perfect cube radical here. Okay, so now off to the side, I'm just going to make a list of the first however many perfect cubes. All right, so if we're taking a look at numbers, right? If we had, let's just say, 1 to the 3rd power, that is equal to 1. If we had 2 to the 3rd, that's equal to 8. If we had 3 to the 3rd, that's equal to 27. 4 to the 3rd is 64, and so on. So what's going to happen is, I'm just going to put a dot, dot, dot. This list represents all of our perfect cubes, although it would keep going. Now let's take a look at variables. If we had x and we raised it to the 3rd power, that's just x to the 3rd. If we had, let's say, x squared and we raised it to the 3rd power, when you have a power to a power, you multiply those exponents, so that would be x to the 6th. If we had x to the 3rd and raised that to the 3rd power, it would be x to the 9th. So this list would just keep going and keep going. And what you could notice, I'm going to put a dot, 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 is that all of these are perfect cubes as long as the exponent is a multiple of 3, or as long as it's divisible by 3. Okay, so let's go back to our original problem now. So let's first take a look at the 128. Well, if we look at our list of perfect cubes, the biggest perfect cube that divides evenly into 128 would be 64, because 64 times 2 gives you 128. So we'll put a 64 here and a 2 here. So now let's look at x to the 9th. Well, 9 is divisible by 3. So this x to the 9th is a perfect cube. So we could take the whole thing and put it in our perfect cube radical. Now, y to the 8th is not a perfect cube because 8 does not divide evenly by 3. So what we want to do is we want to pull out the biggest perfect cube possible, which would be y to the 6th. 6 is the biggest exponent that's less than 8 that divides evenly by 3. And that would leave us with y squared. That would leave us with 2 y's left over that we need to put in our non-perfect cube radical. All right, so from this point, all we have to do is we just have to take this first perfect cube radical and simplify it. So the cube root of 64 is 4. The cube root of x to the 9th is x to the 3rd. The easy way to do it is just take whatever the exponent is and divide it by this root right here. So 9 divided by 3 is 3, so it's x to the 3rd. Same thing with the y to the 6th. 6 divided by 3 is 2, so it would be y squared. And just take your non-perfect cube radical and just bring it down. So this is your final answer.